Hello, everyone. Very good morning, dear students. How are you all? And how about your studies? I hope it should, I hope it should go well. It should go well. It must be going well, isn't it? So, guys, come on. It's so nice to see you all in the morning, isn't it? Once again, a very warm welcome to you all to your very own channel. Let's crack NEET UG in English. Myself, Sharada Alok, I have been teaching chemistry at Resonance from past 10 years. I'm going to teach you today about buffers, solutions, and most of the most important questions. Generally, the questions which are asked, which have been asked on buffer solutions. We are going to discuss all those questions in today's class. Do one thing by the time I'm explaining you to the most important thing, like how to join an academy, what are the benefits of joining an academy, how much, like how you can take the subscription, what will be the benefit of taking subscription. Do one thing, all you guys, please share the link of today's class. Yes, to all your friends who are preparing for NEET 2021 2022, or those who are in class 11 12 or dropper preparing for any other exam but studying chemistry. Do share the link of the video to all your friends, guys, now. So, guys, how you can get connected to us? Let me tell you. First of all, go to Play Store. Done. Then download the Unacademy learning app. Done. Then click on to NEET UG. Done. Before you go ahead for the subscription, let me tell you the type of subscription we are going to have and what are the benefit of taking the subscription of both the type. Guys, the type 1 under the subscription is plus subscription, and type 2 is iconic subscription. I'm repeating, type 1 is plus subscription, guys. What are the benefit of taking plus subscription? Let me tell you, guys. You'll be getting daily live classes. I'm repeating, you'll be getting daily live classes where you'll be taught by the top educators across the nation. Okay, guys, not only that, you can chat with the educator, you can engage in discussion, you can ask all your doubts and answer in the poll all while the class is going on. Let me tell you about the poll. This poll is going to have questions related to the topic being taught by the educator on the screen. Not only that, you'll be getting live tests and quizzes, guys. These live tests are going to evaluate your preparation with regular mock test and quizzes, and you are going to get a detailed analysis on your performance time to time. And trust me, these analysis are going to yes, improve you also from time to time. For example, sorry, for example, in today's test, suppose you are not able to score better. Okay, what is going to happen very soon in the next test? You will definitely score better, guys. You will definitely score better, and gradually, your performance are going to improve. Along with that, you'll be getting structured course, guys. All our courses are structured very much in line with your exam syllabus, which is going to help you to best prepare of. Okay, guys, come on. Just by getting one subscription, you get access to all our live and recorded courses, which you can watch from the comfort of any of your devices. So, this is all about plus subscription. Now, guys, the next one is iconic subscription, which is definitely going to take your NEET UG preparation to the next level with personal coach. What are these personal coach? Yes, the top educators are going to be your personal coach. You are going to get a one-on-one guidance from top exam expert as your personal coach to align your preparation strategy. Not only that, you'll be getting an in-depth test analysis with personalized feedback to improve your time management and exam approach, guys. So, guys, so along with all, you'll be getting a proper study planner looking all your requirements into mind, and it is going to ace your preparation with customized study plan. Along with that, you are going to get a bi-weekly review, which is definitely going to improve your academics gradually. That will highlight your progress, and that will, yes, make you Prepare better day by day, and it is going to ensure your every success into the target you're looking for. So guys, just by getting one iconic subscription, you'll be getting all the benefits, whether you talk about personal coach, test analysis, or study planner, or the quizzes, mock test, whatever we are going to have. You are going to get all of them, guys. So this is all about iconic subscription. Now you must be wondering whether to go for plus subscription or the iconic one. Let me tell you, whatever you are going to get under plus subscription, you'll be getting under iconic as well, guys. But iconic subscription is going to have these iconic features, whether you talk about personal coach, study planner, expert guidelines, or in-depth test analysis. So guys, you have to select a subscription plan that is going to suit you. Whatever suits you, you go for that. Now, guys, how much you have to pay for iconic one? Let me tell you, because it is going to help you better compare both. Okay, guys. Now the features have already been compared. Now, how much you have to pay? Let me tell you. For 6 months, you're supposed to pay 38,000. For 12 months, you will have to pay 65,000. For 24 months, you're supposed to pay 1 lakh. But if you apply this referral code of mine SA10, guys, for 6 months, you're supposed to pay 34,200 only. For 12 months, you'll have to pay 58,500 only. For 24 months, you'll have to pay 90,000 only. If you apply the referral code, guys, along with the discount prices, which just now I shared with you, you will be also getting some other benefits which you will come to realize once you take the subscription applying this referral code of mine. So many helps you will be getting from my side. Yes, guys. So guys, how much you have to pay for plus subscription? Let us see that too. For 1 month, right from 1 month to 2 years subscription are there on the screen. Okay guys, right from 1 month to 2 years subscription are there on the screen. Yes, guys, you can see for 1 month you'll have to pay 7,000. For 3 months you'll have to pay 17,500. For 6 months you'll have to pay 28,000. For 12 months you're supposed to pay 38,500, and for 24 months you should pay 56,000. But if you apply this referral code of mine, guys, you will have to pay only guys, for 1 month you are supposed to pay 6,300. For 3 months you'll have to pay only 15,750. For 6 months you'll have to pay 25,200. For 1 year you'll have to pay 34,650. I would recommend you must be wondering, if you are in class 12 or a dropper student, you must be wondering in taking whether to go for 6 month subscription or to go for 12-month subscription. I just now told you, I just want to tell you that 2 days back, 2 days back, the notification for the notification of the examination of NEET, whether it is going to happen on 2nd of May or not, yes, got postponed. Come on, guys. So we never know, like we are not sure whether it is going to happen on 2nd of May or will get postponed. So, but it is very much sure that it is not going to happen before that. It will happen only after that. Okay, on or after that. So, guys, chances are there that it will happen after 2nd of May. So, what is going to like what you should think for this, for 6 months, if you want to go for, by the end of subscription, you will be still left with 1 or 2 months. Trust me, and that time you're going to realize that you should either go for 1 month or 3 months. Okay, suppose if you are a dropper student, this is okay for you. But if you are a class 12 student, I would recommend you that you should go for this 1 year subscription, guys, because ho gaya to acha, otherwise we will use this for the next year too. So guys, all those who are a dropper student can think for 6 months, but I would suggest recommend personally to all those who are class 12 student to go for 1 year subscription, and all those who are in class 11, please go for this 2 year subscription, guys, by paying 50,400, because class 11 student must be wondering, आधा साल तो निकल गया, almost 6 months are gone now. So, Soumya Deep Pramanik, welcome to the class. Very good morning, Soumya Deep. How are you, dear? Do let me know about your studies, Soumya Deep, and which class you are in also. So, guys, coming back to the screen now. So it is very, very clear from now that 6 months are gone. You must be wondering ki why to go for this 2 year subscription. I just want to tell you that if you want to go for 1 year subscription, you will further have to will feel that you should go for 6 more months subscription. By that time, the subscription for 6 months will also rise. Okay, guys, in any case, it is going to be much, much, much more than, yes, the altogether price, if you will calculate for 12 months and then 6 months, it is going to be much, much, much more than 50,400 by the time. Therefore, I just want to tell you there is no point in overthinking over this. This is no doubt most economical even now, guys. For therefore, you should go for 2 year subscription by paying 50,400 if you are in class 11. Okay, guys, there is no point in paying more. There is no point in regretting in the future regarding this. Okay. And don't forget to apply this referral code of mine SA10 in order not only to avail this discount prices, but to avail some additional help which you will come to know from my side later on, because there are so many things, whether you talk about practical examination, because everything is going to happen for sure, or subjective, like how to approach for subjective. Personally, I am going to help you all, guys, don't worry. So guys, let us start, for which we all are gathered here. Come on, buffer solution. We are going to discuss most important questions of buffer solution. But before that, let us know what buffer solution are. What buffer solutions are, how do they behave, what is buffer action, how to calculate the pH, how to make buffer solution. Okay, because everything is asked in the form of question, guys. Okay, guys, but do one thing. Take a pause. Take a pause and share. First of all, like the video if you all are watching. Share the link of the video to all those friends who are in class 11, 12, preparing for NEET 2021, 2022, or yes, preparing for J mains or advanced class 12 boards, class 11 boards, I mean, half yearly examination, school examination, and of course, KVPY. Share the link to all of them, guys. Okay, share the link to all of them. They are all going to get benefited out of it. Come on, now, all your eyes on the screen. Take a pen and copy in your hand and ensure that you are not going to get disturbed for this another hour. Okay, guys. Okay. So, what are buffer? Buffer are the solution, guys, which are going to resist the change in pH, either on addition of small amount of acid or addition of small amount of base. Remember, either on addition of small amount of base or addition of small amount of acid, their pH are not going to change. We know them as buffer. We call them as buffer solution. They resist the change in pH on addition of small amount of acid or base. They are called as buffer. Trust me, guys, from the very first slide, I am trying to cover all the questions right from the beginning, basic questions to the numerical, everything I'm going to cover in this class. Priyanshi Yadav, hello beta, very good morning to you, dear. How are you, Priyanshi? Soumyadeep, you didn't tell me that which class you are in. All those who which class you are in, do let me know in the chat box as well. And trust me, guys, trust me, you all have to, if you will, you all, first of all, you all have to participate in answering in the chat box whatever question I ask on the screen. Please try to answer in the chat box if you really want to get full benefit out of this class. Secondly, I'm going to cover all the questions, most of the questions, in fact, all the questions. So cannot be possible, but yes, most of the all the type of questions which can be asked on buffered solution, that I'm going to cover in the class. So just all your eyes on the screen, guys, and remember, line to line, everything from NCERT is going to be discussed on the screen. Okay, Yash Kumar, hello beta, very good morning, Yash. How are you, Yash? Priyanshi, Soumyadeep, do let me know in the chat box. And how about your studies? Come on. We all have to gear up to study, isn't it? So have a look, and in the morning, it's really great to study, isn't it, guys? Have a look at the screen. So water buffer solution, guys, we have already discussed. Buffer solution are those which can resist a change in pH even on addition of small amount of acid or base. So buffer solution is a solution which resists a change in its pH when small amount of acid or base is added into this. Okay, this Uncle G is also saying the same definition. Now, this Tony G is asking, what are buffered solution? Hello, beta. Very good morning to you all, guys. Come on, have a look at the screen. Now, guys, what is buffered solution? Let us answer this question first of all. हाँ जी, हाँ जी। ये बफर सॉल्यूशन क्या होता है? अगर ये पता चल गया तो देखो आपको ऐसा मजा आएगा, हंसेंगे हम लोग भी, isn't it? We'll be happy. Just joking. Yeah, guys. Buffered solution is a solution able to maintain its hydrogen ion concentration. If hydrogen ion concentration will be maintained, means what is going to be maintained? Yes, what is going to be maintained? pH is going to be maintained. Namaskar, beta. Pitaji, namaskar. pH is going to be maintained with only minor changes on the dilution. Remember, on addition of small amount of acid, it is going to make a minor change on the dilution because volume wise you are going to add. Solution will have some volume. Or addition of small amount of, yes, either acid or base, guys. So they are, guys, going to maintain their pH on, yes, on addition of small amount of acid or base. Okay. What are the uses, guys? Buffer solution are used in fermentation. Remember, what are buffer solution? MCQ question have been asked as which of the following definition is correct for buffer solution. So remember the definition of buffer solution, or this question has been asked under the head uses. What are the uses, or which of the following are used? Buffer solutions are used in which of the following? That way the question can be asked. So whenever you are studying, correct method to study any topic is to concept the clear. Along with that, you should be familiar with the type of questions you are going to be asked, type of question you have to appear for. Okay, guys. Now, so buffer solution are used in fermentation. It is used in food preservative, drug delivery. Yes, guys, drug delivery, electroplating, printing, the activity of enzyme are very much pH prone. Blood, guys, blood, oxygen carrying capacity needs specific hydrogen ion concentration. And remember, blood itself act as a buffer. So solution of weak acid, yes. Guys, basically what are buffer solution? They are basically solution of weak acid and its conjugate base, or weak base and its conjugate acid. They are basically type of buffer we have. Okay, they are able to maintain pH and are called as buffered solution. I'm repeating, buffered solutions are basically weak acid and its conjugate base. Guys, question have been asked on this also, so be very particular which of the following are true for buffered solution. They are the mixture of, first one, weak acid or conjugate acid, or weak acid or conjugate base. Of course this is correct. Or guys, weak base and its conjugate acid. Is that clear? They are basically buffer. Weak, remember, weak has to be there. Strong acid, first of all, they ionize completely. They do not form their conjugate base. Okay, guys, if strong acid is written and conjugate base, that is wrong. So be very particular about the V, sorry, about the way you'll be asked questions, about the way you should answer the question. Okay, guys. Now, guys, now on the basis of weak acid and conjugate base, or weak base and conjugate acid, type of buffer, guys, there are two type of buffer basically. The two primary type, into which buffered solution are broadly classified into are acidic and alkaline buffer. Very, very important, guys. Acidic buffer and alkaline buffer. What are acidic buffer then? I'm repeating, what are acidic buffer then? Guys, very, very important, because you are supposed to answer like which of the following pair make acidic buffer, or which of the questions are asked like this, which of the following pair make acidic buffer or basic buffer. Are you getting this? Are you getting this, guys? So how to identify that? Let us have a look at the screen. Let us have a look at the screen, and all those who are watching, if you have not liked the video, do so. If you have not shared the video, do so. If you have, all those who are watching but not subscribed the channel, let's crack NEET Eugene English, do so, and do press the bell icon in order to have further notification, guys. So have a look at the screen for acidic buffer. As the name suggests, these solutions are used to maintain acidic environment, because acidic buffer has to have a pH less than 7. Yes, yes, guys, is that clear? So they are going to maintain acidic environment. Acidic buffer has acidic pH that is less than 7 and is prepared by mixing a weak acid and its salt with a strong base. Remember, it is prepared by mixing a weak acid plus salt of weak acid with strong base. Don't worry, we are going to cover the example. For example, guys, acetic acid is a weak acid. It is mixed with, it's a salt with a strong base. Now acetic acid plus NaOH is the, this is the strong base, this is the weak acid, guys. Together they are going to form the salt CH3COONA. Is that clear? So guys, acidic buffer, one of the acidic buffer taking acetic acid and sodium acetate. Yes, yes, is that clear? Are prepared, guys. These two, mixed and acidic buffer, are prepared. Acid, and you have to take a salt of the acid with a strong base. Is that clear? Is that clear, guys? Come on, if it is clear, note it down. Note it down, guys. Now, an aqueous solution of an equal concentration of acetic acid and sodium acetate has a pH 4.74. I told you the pH has to be less than 7. Now, guys, pH of these solution is below 7. Yes, that is all clear. These solution consist of a weak acid and a salt of a weak acid. Just now I explained. Acidic buffer solution is a mixture of sodium acetate and acetic acid. The pH of that is 4.75. Now, guys, what are alkaline buffer? Let us look at the screen. Alkaline buffer, guys. What are alkaline buffer? Let me tell you. Guys, alkaline buffer solution are used to maintain basic condition. Come on, acidic buffer, as the name suggests, acidic condition. Alkaline buffer, as the name suggests, maintain basic condition. Is that clear? Come on, is that clear, guys? Now, basic buffer, of course, they will have a pH of how much? Yes, they will have a pH more than 7. Is that clear, guys? They will have a pH more than 7. Basic pH means what? The pH has to be more than 7 and is prepared by mixing a weak base. By mixing a weak base plus, guys, what? And it's salt with a strong acid, plus the salt of weak base with strong acid. Let us take, guys, let us take a weak base. Can you name a weak base in the chat box? This is a weak base and it's salt, and the weak base plus HCl, which is a strong acid. This is a weak base. This is strong acid. SA stands for strong acid. WB stands for weak base. On mixing, it is going to form the salt NH4Cl. So NH4Cl is a salt of the weak base with strong acid. Guys, the buffer is going to be made by mixing the two. Is that clear? Is that clear? So, basic buffer has a basic pH and is prepared by mixing a weak base and its salt with strong acid. The aqueous solution of an equal concentration of ammonium hydroxide and ammonium chloride has a pH 9.25. That is much more than what? 7, isn't it? pH of this solution is above 7. Just now I told you. They contain a weak base and a salt of weak base. Just now we discussed. Example of alkaline buffer solution has a mixture of ammonium hydroxide and ammonium chloride is 9.25. We need not to learn the value, but you have to remember that it is what? It is more than 7. Okay guys, all clear. Now have a look here. Mechanism of buffering action. How does the buffer solution keep their pH constant? Let us have a look on the screen. In solution, first of all, what happens? Just now we discussed that acidic buffer are a solution of acetic acid or a weak acid and a salt with the weak acid with a strong base. So the weak acid is here, acetic acid. Let us take an example. And the salt of acetic acid with a strong base is sodium acetate. So guys, so what is going to happen here? Come on, the salt is completely ionized and the weak acid is partially ionized. Come on guys, the equilibrium symbol will not be here because it is going to completely ionize. So it will have a symbol like this. Done. Entire moles of sodium acetate are going to dissociated as Na plus and acetate ion. All those who are watching, do like the video, do share the video, guys. Do like and do share the video. It is completely ionized. Okay, all done. Now guys, have a look at the screen. Come on. All those who are watching, do like the video, do share the video faster without delay. I'm repeating, do like the video, do share the video without delay. Okay, guys. Okay. In solution, the salt is completely ionized and weak acid is partly ionized. Or you can say weak acid is in equilibrium, guys. So this is how the ionization take place. This is an equilibrium, guys. If it is equilibrium, if H plus or acetate ion will be added to this, the equilibrium is going to shift backward. Le-Chatelier principle as per or guys, if H plus or acetate ion concentration are lesser, it is the equilibrium is going to move forward. We know all this. So guys, how come that is going to help the maintain the pH? Let us see now. Suppose we have added a small amount of acid. What is going to happen on adding small amount of acid? Acid is going to release the proton, guys. Whatever acid will release what? Proton. H plus is going to be released. H plus is going to be released, isn't it? All those who are watching, do like the video, do share, and if you have not subscribed the channel so far, do so. If you have not pressed the bell icon, do so. So guys, acid is going to release H plus. The released proton of acid will be removed by the acetate ion. What is going to happen? H plus, guys, excess is ion is there in the product side. Le-Chatelier principle. Le-Chatelier's principle says that on addition of small amount of acid, yes, H plus, what is going to happen? This acetate ion is going to, the equilibrium will move in a shift in such a direction so that there should not be any effect of H plus ion added to the solution. As per Le-Chatelier principle, what does Le-Chatelier principle says? It is going to, whatever change is introduced to an equilibrium system, the reaction will try to, or the equilibrium will move in a or shift in a direction so as to minimize the change caused by, yes, by the guest appearance of the guest, isn't it? Le-Chatelier principle says that. I'm repeating, whatever change is there introduced into an equilibrium system as per Le principle, equilibrium will shift in a direction so as to nullify the change. This is as per the Le principle. Is that clear? So we have added H plus. Equilibrium is going to shift in a direction so as to nullify the effect of H plus. So what is going to happen? Acetate ion is going to combine with H plus and going to form weakly ionized acetic acid, or you can say the equilibrium will shift in a backward direction on addition of H plus. Is that clear? Or you can say this is how H plus, extra added H plus is going to be removed from the solution, so it will not able to change the pH of the solution. Is that clear, guys? Is that clear? So H plus and acetate ion from added acid, yes, H plus from the added acid, it is going to form acetic acid. Okay guys, unionized, weakly ionized acetic acid. This is how the change due to H plus is going to be nullified. Now what is going to happen on addition of small amount of a base? Guys, base is going to add what? It is going to add the OH minus. Now, if OH minus is added to this equilibrium, let me tell you what is going to happen here. Yes, guys, if OH minus will be there, what is going to happen, guys? H plus is going to combine with OH minus and going to form water molecule. Yes, stable molecule. It is not going to ionize. Now, guys, you must be wondering, okay, stable molecule to ban gaya. What about the dilution going to be created by this? As we have studied the definition of a buffered solution on addition of small amount of acid or a base, the pH is not going to be changed. So the OH minus volume is less. I mean the water molecule which is going to be formed by this is also less. The volume due to formation of water molecule is less. So it is not going to dilute. Very little dilution is going to take place. Little dilution. And that little dilution is not going to hamper the pH of the buffer. Is that clear? Is that clear, guys? Come on. All the questions have been asked, guys. How the pH is like come on, let me tell you what all questions can be asked over this. First of all, guys, first of all, what happens during, like, what is an acidic buffer? What is a basic buffer? Which of the following can be acidic buffer, or which of the following makes basic buffer? Or, guys, what will happen to the equilibrium of this acidic buffer on addition of small amount of H plus, on addition of OH minus? What, why does the pH not change on addition of H plus? Why does the pH not change on addition of OH minus? Okay guys, so almost 8 to 9 type of questions which I have discussed just now will be asked on this. Now let us go ahead, guys. Mechanism of buffer action. As just now we discussed, this is not an equilibrium, guys. It is going to ionize completely like this. Okay, guys. Okay, have a look at the screen. Guys, sodium acetate. Let me take a red pen. Come on, have a look here. Acetate buffer. This is going to completely ionize as this, and this will be in equilibrium with acetate ion and H plus. On addition of small amount of H plus, what is going to happen? Or on addition of small amount of OH minus, what will happen? Suppose you have added a 1 mole of a base. Guys, the base is going to give you OH minus. Now that OH minus will take up the H plus from acetate ion and will form weak electrolyte, that is what? Water. Is that clear? So 1 mole of water is going to be formed over here. If you add 1 mole of HCl, what is going to happen? It will form 1 mole of acetic acid. So guys, what is going to happen? Both of them are weakly ionized. So therefore, there won't be any change in the pH. So this type of reactions, just keep in your mind that can be the, like, which of the following is representing the mechanism of buffer reaction kind of question can be asked over it. Is that clear, guys? Come on. Or like on addition of OH minus, what is going to form? On addition of H plus, what is going to form? These type of questions can be asked. I just want to tell you, all those who are watching, do like the video, do share the video so that more of your friends can watch this. And all those who have not subscribed the channel Let's Crack NEET Eugene English, do so. If you have not pressed the bell icon, do so. Come on, guys. Preparation of buffer solution. Let us see how can we prepare the buffer solution. Come on, guys. If the dissociation constant of the acid, okay, and of the base or the pK or pKb are known. A buffer solution can be prepared by controlling the salt acid or salt base ratio. Very, very important thing, guys. You have to control the salt acid or a salt base ratio. Okay, as discussed earlier, these solutions are prepared by mixing the weak base with the corresponding conjugate acid. Initially, I have explained this, or by mixing weak acid or with the corresponding conjugate base. Okay, guys. So one of the example is phosphate buffer. Guys, acetate buffer, you have seen that acetate buffer, you have seen that ammonium buffer. We had just now prepared NH4OH, NH4Cl, one type of a buffer, which was alkaline buffer. Then acidic buffer, acetic acid and sodium acetate. One more buffer is phosphate buffer, which is prepared by HP4, HPO4 2 minus and H2PO4 minus. The pH maintained by this solution is 7.4. See, guys, acidic buffer was somewhat 4.74 between acetic acid and sodium acetate. Acetic acid and sodium acetate. The pH of this buffer was somewhat 4.74 roughly. Okay, guys. Okay, and the another one, guys, NH4OH and NH4Cl, it was somewhat around 9.25, isn't it? Somewhat 9.25 something value. But this buffer has got a pH of 7.4. 7.4, guys. Okay, remember that. Come on, why it is possible, let me tell you. You all guys know phosphoric acid is a tri basic acid with the formula H3PO4. Okay, guys. First of all, one proton goes out from this and it forms H2PO4 minus. Now, guys, this is an acid. This is a conjugate base. If you compare the two, guys, if you compare the two, this is an acid and this is a conjugate base. It can further accept a proton or it can release a proton. You can say this is amphiprotic. Amphiprotic species are one which can take up the proton and form an acid, or which loses the proton and form a base. For example, H2PO4 minus on further losing a proton will form HPO4 2 minus. In this case, guys, this is acting as an acid and this is a conjugate base of this acid. So this one is amphiprotic. As on accepting the proton, the equilibrium shifts backward and forms phosphoric acid. On losing the proton, guys, it forms what? On losing the proton, it forms its conjugate base and the equilibrium shifts, yes, forward direction like this. Okay, guys. So this is an amphiprotic species. Come on, guys. Come on, let us go ahead. Let us go ahead. This loses the proton further because it is a tri-basic acid. On losing the entire proton, it converts into phosphate ion. Remember, in this case, this phosphoric acid is actually only the acid. This is only the base where it can accept a proton, and this is an acid where it can lose the proton only. Whereas the two species, both of them can act as acid as well as base. Guys, therefore both of them are amphiprotic. If you mix them, it is going to form a phosphate buffer. What it is going to form? It is going to form a phosphate buffer. All those who are watching, if you have not liked the video, do so. If you have not shared the video, do so, guys. This is very, very important. The pH of phosphate buffer is just slightly alkaline, 7.4, and the reason behind that is there on the screen. Okay, why just slightly alkaline? Now, guys, now have a look at the screen. Preparation of acidic buffer. We had just now seen preparation of basic buffer. Now let us see preparation of acidic buffer. Consider an acidic buffer solution containing weak acid and its salt Ka with a strong base KOH. Guys, weak acid ionizes and the equilibrium is written as, just now we had seen, this is how the equilibrium will be written as. You can make it as H3O plus and A minus. Acid dissociation constant can be given by what? Ka of the acid is going to be the product of the concentration of hydronium and A minus upon concentration of Ha. Why do we not take the concentration of water with respect to Ha, guys? Ha, the concentration of water is too high, therefore it is neglected over here. Therefore the dissociation constant can be given by H plus and A minus upon Ha, the concentration of Ha like this. Is that clear? Now guys, taking negative log of RHS as well as LHS. RHS as well as LHS, guys. Okay guys. So what is going to happen? Negative log of Ka. Let me write over here. This will be negative log of Ka is equal to negative log of H plus negative log of, just a sec, guys. Negative log of A minus upon Ha. It can be like that. No problem. It can be like that or not. Yes, it can be. Or guys, this can be written as pKa. Negative log of H plus can be written as pH. Yes, negative log of A minus upon Ha. Is that clear? Now this pH can be this remain this side and pK can be added with plus log of A minus upon Ha. This is how. So look into the inbox over here. So if you bring this log salt by acid on the other side, it is going to form pH is equal to pK plus log salt by acid. Log salt by acid. This is how the formula is going to come out. Guys, this is a very famous formula to calculate the pH of a buffer and is called as Henderson-Hasselbalch equation, popularly also called as Henderson equation. Come on, it is Henderson-Hasselbalch equation. Guys, very famous equation, Henderson equation. Which of the following formula is Henderson equation or Henderson-Hasselbalch equation? Or guys, or no doubt, this is the elementary question which can be expected out of it. Okay, along with that you'll be having numericals. You'll be given out of the four, like pH 1. There are four variables over here. Suppose pH 1, pK is second one, concentration of conjugate base is third, and concentration of the acid is 4. Out of the 4, any 3 will be given. The fourth one will be asked to calculate. Okay guys, this is how the question can be possible over this. I hope it is straight away going here. Now guys, let us have a look at the next screen. Come on guys. Sorry. Okay, preparation of basic buffer. Just now we had seen that. Consider base buffer. How the basic buffer can be made? By adding the weak base and the salt of the weak base with the strong acid. Done. Now guys, now as their basic buffer, first we have to calculate POH. Okay guys, pH of a basic buffer will be equal to pKb plus log salt by acid. It is very easy guys, very easy. The formula is same. If pH is there, pH of acidic buffer will be pK plus log salt by acid. POH will be yes, pKb plus log salt by acid. Is that clear? The formula is very simple. But in order to calculate the pH, you have to subtract this pH from 14. You all know that. All done guys. So pH of a basic buffer is equal to pKa minus log salt by acid. All done guys, all done. Now what is the significance of Henderson equation? Henderson equation can be used to, first of all, we know that it is used to calculate the pH of the buffer prepared from a mixture of salt and a weak acid or with a weak base. Done. It is also used to calculate pK value. It is also used to prepare buffered solution of needed pH. Yes, needed pH. If we know the pK and pKb value, it is going to help the prepare buffered solution of a needed pH. Very important guys. Which of the following are the uses of or the significance of Henderson equation. This is how the question can be asked. Or which of the following formula will help you to calculate pOH of a buffer? Is that clear? Or pH of a buffer? So these are the type of question which can be asked over this. All those who are watching, if you have not liked the video, do so. If you have not shared the video to all your friends who are preparing for NEET 2021, 2022, do so. You can share the video to them also who are preparing for mains or advanced, who are preparing for board examination, who are preparing for KVPY as well. Now guys, now limitation of Henderson's Hasselbalch equation. Limitations, very important guys. Question can be asked over this also. Limitations of, what are the limitation of Henderson Hasselbalch equation? Guys, this cannot be used for strong acid and strong base. Very important guys, this cannot be used for strong acid and strong base. Keep it in your mind. Now the very important one guys, buffering capacity. I'm repeating, buffering capacity. What is buffering capacity guys? Number of millimole of an acid or a base to be added to a liter of buffered solution to change the pH by 1 unit is called as buffer capacity, also called as buffer index. Also called as buffer index. Okay guys, now it is calculated by the formula. Buffer index is millimoles of either acid or base added by change in pH caused by addition of acid or base. Is that clear? Millimoles by change in pH caused by addition of acid or base. Guys, more the moles of acid or base, higher is the buffer capacity, because buffer capacity, you can see, it is directly proportional to millimoles of acid or base added. Okay guys, so more the moles of acid or base added, more is the buffer capacity, and less the change in pH caused by it means more is the buffer capacity. More change means less is the buffer capacity, or less is the buffer index. Remember, this buffer capacity is also called as buffer index. Is that clear guys? More the moles of acid or base required to change the pH of the buffer means what? The buffer capacity is very high. Okay guys, buffer means what? Which do not let its pH change on addition of small amount of acid or base. Okay guys, so they are the army standing over there on the border, isn't it? The better army is what? जो बहुत सारे लोगों को, बहुत सारे इंट्रूडर्स को, बहुत सारे जो बाहर के लोग हैं, अटैकर्स को झेल पाए. Isn't it? Similarly, buffer capacity. The best buffer is that, or higher the buffer capacity means, बहुत सारे acid आओ, base आओ, we are not going to let our pH change. Is that clear? So more the number of millimoles of acid or base added in order to change the pH of the buffer, better is the buffer capacity, higher is the buffer index. Is that clear guys? Is that clear? Question is asked this way also. What is the buffer capacity if this much millimole of acid is added, this much millimole of base is added? Okay guys, and the pH change is caused by this much pH has been changed. Is that clear? Is that clear? This is very important guys. Like buffer capacity question have been asked, what is the buffer capacity of a buffer? Okay guys, now let us go ahead. Problems on buffer solution guys. Let us practice the problems. What is the ratio of a base to acid when pH is equal to pK in a buffer solution? Okay guys, let us see that. We know that the formula is what? pH is equal to pKa plus log concentration of salt upon acid. Done. Guys, when pH is equal to pK can be possible only when these two are equal. If these two are equal, we'll get as log 1. And log 1 is equal to how much? 0. In that case, only pH can be equal to pKa. Is that clear? Now the second question which is there, how about when pH is equal to pKa plus 1? Guys, this plus 1 means what? The log value, log salt upon acid, this value is 1. Okay, in this case, the second equation, pH is equal to pKa, means what? This value, the logs of salt upon acid has to be 1. And this can be possible only when the concentration of salt is 10 times to that of acid. Is that clear? Is that clear? So guys, the ratio of salt to acid should be, ratio of salt to acid, it should be log 10 upon 1, or the ratio should be 10 upon 1. Is that clear? Is that clear? Then only this situation is possible. I hope you are getting this. All those who are watching, do like the video. If you have not done so, do share the video if you have not done so. Now guys, now let us see the next question. Calculate the pH of a solution obtained by mixing 5 ml of 0.1 molar ammonium hydroxide. Remember, this is the weak base, with 250 ml of 0.1 molar NH4Cl solution. Kb for the weak base is given, guys. Okay, what type of base it is? It is going to be an alkaline base. Is that clear, guys? Is that clear? Now guys, Henderson-Hasselbalch equation for acid and its salt. pH is given is equal to pK plus log salt by acid. pH for the base is given as pKb plus log salt by acid. Very, very simple. Let us see how to calculate this. 5 ml of 0.1 molar NH4OH, guys. Remember, means how much millimoles of NH4OH, guys? How much millimoles? M into V, that is 5 into zero point 0.1. This is going to be how much? 0.5 millimole. 0.5 millimole. Is that clear? 5 into zero point 0.1 will be 0.5 millimole. Okay, guys. Now, 250 into zero point 0.1 will be 250. Yes, yes, 250 ml of zero point 0.1 mole of NH4Cl will have a millimole. How much? Yes, it is going to be 25 millimole. 25 millimole. Is that clear, guys? This is the millimole of this, millimole of the, this is millimole of the base, this is millimole of the salt. Is that clear? Is that clear? Because in order to use this formula, you must have the concentration of salt as well as acid. So first we are going to calculate this millimoles of salt as well as the base here. In this case, base is there. So guys, now the total volume, guys, when the two are getting mixed, the volume will also change. What is the total volume, guys? How much is the total volume? 5 ml of the base is mixed with 250 ml. So guys, the total volume is going to be 255 ml. Is that clear? Total volume is 255 ml. Now this much millimole of the salt is present in 255 ml. Remember, this is also very, very important. Generally, we ignore the volume, which we should not do because it is dangerous for the numerical to be correct. Isn't it? Isn't it, guys? So how much the concentration of the salt in the buffer is coming out to be? Very simple. 25 millimole divided by the volume. The volume is how much? 255. Is that clear? How much concentration of the base in the buffer? Millimole is 0.5 upon the volume 255. Is that clear? This will give you the molar concentration. Is that clear, guys? Now just put on the value. We have to be, as it is alkaline buffer. Therefore, let us apply the second formula. POH is equal to pKb plus log salt by base. Is that clear? Now pKb is given here. So pKb, guys, Kb is given. pKb is negative log of that. pKb is equal to negative log of Kb. Is that clear? So it will be negative log of 1.8 into 10 raised to the power minus 5 plus log salt. How much salt is there? Salt is there log 25 upon 255 upon zero point 0.5 upon 255. 255 is going to get cancelled. We'll be getting negative log of 1.8 into 10 raised to the power minus 5 plus log how much? 250 by 5. 250 by 5. Okay, guys. Okay. Now let us take the log. Negative log of 1.8 is how much? Come on, guys. Don't worry. You will be given the values of log. You have to simply put on the values over there in the formula. All those who are watching, if you have not liked the video so far, do so. If you have not shared the video so far, do so. If you have not subscribed the channel so far, do so. If you have not pressed the bell icon so far, do so. So guys, log 1.8, the value is 0.2553. Come on, this will be minus 0.2553, and negative log of 10 raised to the power minus 5 has to be plus 5. Log 10 and log 10 is 1, therefore it is going to come out as plus 5. Plus log 50. Guys, log 50. Why log 50? Because 250 upon 5 is log 50. How much? What is the value of log 50, guys? The value of log 50 will be given, and it is 1.6990. Just put on that. 1.6990, and on solving this we get the POH. Remember, we are calculating the POH बहुत शांति से करना है, because I have seen most of the student, yes, because in the option, guys, remember, this value will also be given, but remember, you have to read the question carefully. In the question, POH is asked. Sometimes POH will be asked. So be very particular what is asked in the question and which option you are supposed to click as the correct one. Okay, guys. So POH value is 6.4437, but we have to click for pH. In order to calculate pH, subtract this POH from 14. And guys, this value will be what? This value has to be 7.5563. Is that clear? One more thing, guys, one more thing. Ask yourself what type of buffer it is. The buffer is what? Alkaline buffer. We have already seen that an alkaline buffer will have a pH more than 7. So that is how you can compare the answer, whether you are going correct or not. I'm repeating. Guys. First of all, read the question carefully. What is asked? In this question, pH is asked. Secondly, what all informations are given? Third, guys, third what? Third what? Come on, guys, using the correct formula. POH, the formula is this. First calculate the POH, and then as you're supposed to calculate pH, so subtract the POH from 14. And then, as in the question, what is being asked? Alkaline buffer, basic buffer. Isn't it? Ammonium hydroxide and ammonium chloride is going to form what? Basic buffer. So it has to have a pH more than 7. I hope straight away you are getting here. And don't worry for the log tables. Most of the students keep worrying, ma'am, log table aa gaya, log table to milta nahi hai, dekhenge kaise ye wo. Don't worry for that. You will always be given the value of log. Okay, guys, on log table. Yes, guys. If log table, yes, want to see how to calculate the value of log, don't worry. In a separate video, I have made, in fact, and I'll make it again also. I've taught to calculate how to use the log table. Don't worry. I've already taught how to use the log table. Now, guys. Now, the last expected question under this is uses of buffer solution. Very important, guys. In our life, buffer solutions are very important, guys. I initially told you that our blood, or most of the, like, our body or living organism, whether plants or yes, we the social animal. Yes, Aristotle, man is a social animal, isn't it? Yeah. So for all of us, all living organism, yes, guys, we depend on enzymatic activity, and all enzymatic activity are highly prone to pH. Okay, guys. So let us have a look here. Uses of buffer. The first use, guys, the first use, exist a few alternate names that are used to refer buffer solutions, such as pH buffer, hydrogen ion buffer. Guys, come on. This is actually not the use. This is all about the use. Okay, guys. Now the use. Where the pH buffer, pH, yes, use of buffer in pH regulation is the use of bicarbonate or a carbonic acid buffer system in order to regulate the pH of an animal blood. Yes, this one is the UH. Okay, what type of, come on, guys, blood is a buffer. Now, what type of like buffering system is over there? Actually, it has bicarbonate and carbonic acid. Let me tell you. Guys, carbonic acid is H2CO3 weak acid, so there has to have H plus and HCO3 minus ionization. And guys, bicarbonate, a salt is of bicarbonate, so it has sufficient amount of this bicarbonate salt. Is that clear? Now what is going to happen on addition of small amount of acid to it? On addition of small amount of acid means you are adding H plus. It is going to combine with bicarbonate ion and it is going to form an unionized carbonic acid. This is how it is going to nullify the change caused by small amount of H plus. What will happen if base is added? It is going to combine with this H plus and going to form an unionized or weak electrolyte like water. And this is how on addition of OH minus, it is going to resist the change in pH. So this is how our blood act as a buffer. I'm repeating, this is how our blood act as a buffer, guys. Very, very important thing over here is what type of reaction. Yes, guys. Use of bicarbonate and carbonic acid. So our blood is having bicarbonate and carbonic acid buffer system. Very, very important question. First one, is blood a buffer, or which of the following act as a buffer? So blood is a buffer. What type of buffering system over there? I mean, what is the reaction over there? This is the question is there. I mean, the answer is there on the screen. And all those who are watching, don't forget to like the video. Don't forget to share the video. Okay, guys. Now the next one. Buffer solution are also used to maintain optimum pH for enzyme activity in many organisms. Optimum pH. Okay, guys. Now, absence of these pH will do what? Absence of these buffer may lead to slowing of enzyme action. Very, very important. It will slow down the enzymatic action. So they are very, very important. Now, loss in enzyme property or even denature of enzyme, which is actually happen what? At very high temperature, guys. Either at very high temperature or by adding some poisonous substance which are poisonous to those particular enzyme. And that causes what? Denaturation. So this denaturation process can even permanently deactivate the catalytic action of the enzyme. Remember, so how important they are is all clear on the screen, guys. So guys, buffer system are very, very important to maintain our, yes, if blood won't be there, we won't be there, isn't it, to maintain our life? Okay, guys. So guys, all those who are watching, thank you for watching. Don't forget to take this, apply this referral code of mine in order to take the subscription. And all those who are watching, if you have not liked the video, do so. If you have not shared the video, do so. And please subscribe the channel. Let's crack NEET UG in English in order to ensure your every success in NEET UG. Okay, guys, okay. And do press the bell icon in order to have further notification. So guys, thank you for watching. All the very best for your examination.